Right, this is the second video of the modIO setup sequence. Just to remind you, the setup that we've got is two modIOs. This is the new style one, which allows you to daisy chain by RS485 to multiple modIOs. I'm daisy chained to an old one here, and the slave address of this is 2. It has an analog input, it has a push button which is to simulate one of the crossings of the key matrix, and it has an MPG connected to it. The new modIO, which has the power, has a single toggle switch which is connected onto terminal 12. Right, so here's Mach 3. Which we've configured so that it knows that we're using Modbus plugins. We've configured the Modbus to be serial port and running at the right baud rate, and we've added the two modIOs so that it knows what slave addresses they are. And so now we're ready to configure. Let's choose the first modIO. So this is the new one, which has got virtually nothing on it. And now we're going to tell Mach 3 what it's going to do to generate output signals and to accept input signals. So we're configuring Mach 3 for modIO 1. Now modIO 1 has only got the toggle switch on it, and the outputs, we can look at their LEDs. Let's quickly review though what connections you can make. You can connect the pins, so there are 8 input pins, there are 8 output pins. We can connect them to Mach 3 input and output pins on port 0. If we've got encoders or MPGs, then there can be 2 on a modIO, and we can connect them up to either the encoder inputs or the MPG inputs of Mach 3. The analog inputs, there are 3 strict analog inputs on the modIO, and we can connect them up to DROs or to a memory buffer that a macro pump or another VB script can access. We'll see when we're setting up analogs that you can scale the value you get so that it's convenient to the values that you want in Mach 3. These are on the analog page, although they're not strictly from electrical analog inputs. There is an input which will give a period, so that is the time between index signals coming from the digispeed, and that can be converted into an RPM value depending on how many slots there are in the index sensor. Right, if we've got a switch matrix, then that is 16 inputs. We can define what pins of Mach 3 port 0 they are to be connected to. The LCDs have 4 lines on them, and we can write data to them by putting what we want into either user labels on the Mach 3 screen, or we can display some of the standard labels like the error line, the name of the current G-code file, or the name of the current profile. And finally, for programming use, you can connect any Modbus register up to either any Mach DRO or any number in a buffer that can be accessed by a VB script. Now, this modIO is set up in a very simple way. Let us define its 8 inputs to be pins 0 to 7. And its 8 outputs to be pins 0 to 7. These will be on port 0. I'll come back to these diagnostics in just a minute. So they're already set up. So if a signal... right, now then, it's complaining because modIO 2 is also set up in the same way, so it's clashing with those pins. So in fact we need to just fix that straight away. modIO 2, let's configure it so it starts with its inputs at pin 8 of Mach 3 and its output's at pin 8 of Mach 3. Right, so it's happily configured that. So now, if I go out of configuring, reset I must have ports and pins trouble on Mach 3 inputs. Let's have a look and see what we've got. Yeah, so we've got eStop configured onto pin. So let's configure that onto port 1. Now we can come out of eStop. Right, so ports and pins, we had, you'll recall, port 0 pin, the inputs 0 to 7 of our modIO were connected up to pins 0 to 7 of Mach 3. So let's configure something that we can see in the diagnostic screen. So port 0 pin. Now I've got my switch connected up so that it's connected up to that's port 0. Won't it let me change that? Better. 0, and we change that to remember we had terminals, data inputs 0 to 7 were connected to pins 0 to 7, and my switch is on the 4th input. So if I apply that and reset it and go to the diagnostic screen, if I switch my toggle switch on and off, input 1 switches on and off. Now, appreciate that those mappings are quite complicated. What we've done is we've taken a data input number corresponding to a terminal number in the modIO. We've mapped that into a Mach 3 pin, and then we've mapped that Mach 3 pin into an input. So let's just quickly go through that again, because when you've mastered that, then you'll be able to do any of them. So in modIO, modIO 1, we're configuring it data input 0 to 7, so that is pins 6 to 10 and 12 to 15. Now I'm using pin 12 for my toggle switch. They are connected to 0 to 7. So port 0 pin 4 will be my toggle switch. And so in Mach, ports and pins input 0 to 4 are my input. And so when I look at that input 1, switching the switch toggles it on and off. Now, you'll remember hopefully that we've configured the outputs, pins 0 to 7, are going to be the digital outputs. So if I go to output signals, and if I configure output number 1 to be pin 0, port 0, pin 0, and apply it. Now, changing the active low will change the output LED on and off on my modIO. Now, you can't see it, but the LED is on because the output is false and it's active low, and it's off. And I could configure any number of outputs that I wanted to. If I wanted to configure this output, for example, to be port 0 pin 1, apply that. That now switches on and off the second LED, output LED. So I can control spindles, lights on a panel, whatever, using the outputs, and I can get the inputs off switches. So that is the most simple configuration. Right, let's now look at slightly more sophisticated configurations. And I think the first one to go to is to look at the analog. So I'm going to look at my second modIO, so modIO 2, configuring it. Let's look at its analog. Well, I've got the potentiometer connected to analog input 1, so that is terminal 2 on jack 1 on the modIO. And what I'm going to do is I'm going to define for you the feed rate override to be derived from this potentiometer. So I need to set the feed rate override DRO. So I choose DRO, and the feed rate override DRO, well, I do know that off by heart, but we will assume that we don't. So to get that, I'm going to go to Mach support. I'm going to go to the customizing wiki. And in the customizing wiki there is a list of OEM DROs. So we're looking for the feed rate override DRO. Well, you can either use the find feature of your browser to find it. I happen to know, though, that it's somewhere down in the 800s. One way of finding DROs, of course, is to go into Screen Designer and double click on the DRO, and it will tell you what its number is. So somewhere down here, there we are, the feed rate override is DRO 821. So 821. So this says that the analog input port defines what is written into DRO 821. It doesn't say how to turn a value which actually goes from 0 to 100% into the values in our DRO. Now for a feed rate override we probably want to go from value, it's a percentage, so we probably want to go from value something like 5, and we probably want the maximum feed rate override to be, well, let's say 150. Now the feed rate override is actually a DRO with no decimal places, so it would probably be best to make the modIO driver turn it into integers. Mach will actually do it with that DRO, but there are cases where you want to be certain that you've got integers. So we're configuring modIO 2, that's the one that's got the potentiometer on it. It's connected to analog input 1, that is terminal 2. I'm going to set the value it defines into DRO 821, and when it's wound down right to the lowest value, I'm going to get 5, and the highest value is going to be 150. So I've configured that. If we go to the program run screen, here is the feed rate override DRO, and I've made the mistake that I make so many times, and you will make. When I was configuring, I've done all that work setting up the analog inputs, but I haven't enabled them. It may be that you want to not use them, whatever the values are here. So if we enable that and OK it and close it down, now as I turn my potentiometer, it's wound all the way up, so I get 150% feed rate override, and I'm turning it down, and so it updates the DRO, and because it's a special DRO with a slider, the slider is going as well. So I can change my feed rate override using the analog potentiometer. Now that used to be possible, but required lots of VB script in a micropump macro. But I think you will find that that is quite useful. One of the other good things you can do with an analog input is you can configure it so that let's go back to them, so that it is integral values, and if you put the value into the something like the spindle pulley number and have a multi-position switch with 4 positions, say, and 4 resistors that give you 4 inputs, you would then choose an offset which went from 1 up to 4 and have integral values, and adjusting the switch, or a potentiometer, come to that, would set the pulley number to the position of the switch or potentiometer. So that's quite an easy way of interfacing to select multiple pulleys. So that's analog inputs. Let's look now at LCDs. We go to the LCD. Let's enable it before we start so we don't forget this time. I would like one of my LCDs, this is on the modIO 2 we're configuring. I would like to configure this so that it displays what the error line is. So the first line of the LCD, if I type the value -1 in there and go out of it, well, currently the error line is blank, but if I do a reset, it says E-stop button pressed, and the LCD on the modIO, you can't read it, but I can assure you it says E-stop button pressed. So you can configure that. You can also find which profile you've got running, and you can also find which file you've got for the G-code. Supposing we load up some G-code, might have a recent, there's a simple pocket. So there's the name of the file that I've got. If I now configure plugins, let's just, to show you, configure the new plugin. So this was address 1, and configure its analogs. Each modIO is completely separate. You can configure how it's set up in any way you like, not its analogs, its LCDs. We've got to enable them, and so we want the first line of it to be the current G-code file, so I code -2 in there, and I've now got C:/Mach3/G-code/cutpoc. Not long enough, obviously, for the full file name. Right, so let's now go back to configuring the one that we've got other things on, and have a look at how we can write user-defined text into here. Let's use user label number 10. Now you don't have to have this displayed on the screen. There are 255 of them, 0 to 254. You don't have to display them on the screen. You can display them on the screen so that you can see what's happening, but I will choose 10, which we haven't got on the screen, and I will write a macro. So I go into the text editor, set, and I've actually got a file already. That's quite handy. Let's set user label number 10 to this text string here. That happens to have exactly 20 characters, so you can test that you're seeing them all, and we'll save that in modIO vid macros folder. So this is the macro folder for modIO vid, and we will save it as macro 9999. Right, so back into Mach 3, I've configured my label 10. If I go to the MDI line and input M9999, I get displayed on the second modIO ABCD XYZ. Right, so the final thing that we want to look at now is configuring the key matrix and the MPGs. Let's look at the key matrix first. So you remember I've got the push button switch connected in column 2, row 2 of the second modIO. So if we can configure the second modIO and go to the switch matrix, let's say that switch matrix is going to work on port 0 pin 50 onwards. Here's the matrix. Terminal 6, terminal 7, terminal 8, terminal 9 on the outputs. So those are the drives into the columns of the matrix. And the inputs go into 7, 8, 9 and 10 on the inputs. Now I've got my switch connected in that cell, in other words between column 2 and row 2. So pin 55 is going to work, it's going to be activated by my push button switch. So not forgetting to enable the controls. If I'd got a full matrix, clearly it's going to give us inputs on 50 up to 65, the full 16 switches. And don't forget, if you've got a matrix and you want multiple key presses, you need diodes in the matrix. So pin 55 is going to be active when I press my switch. So ports and pins, input signals, let's enable the, wouldn't be a very sensible thing to use the matrix for limit switches, but they're going to be easy to see on the diag screen. So let's go to port 0, port 0, port 0, and it was pin 55. 55. So now when I press the switch on the keyboard matrix, I should see the limits for the x-axis work on the diagnostic screen. So we go out of reset. So there we are, pressing the switch gives me my limits. If I'd wanted to change the normally open, normally closed, obviously I should have done that over here, active low. The switch I've got is obviously configured. Well, it's actually a normally open switch, so let's apply those. Right, now I press it, I see the limits and the home. So that's configuring the keyboard matrix. You can see that the keyboard matrix is working because the output LEDs glow about half brightness, feeding the matrix, and obviously when a switch is closed then you get a half brightness input. This shows the scanning happening. Right, so finally let's look at MPGs. Well, the easiest thing is to start off looking at just feeding into encoders. So let's enable encoder, and it's going to be, you don't need to configure the pins they're connected to because that's done automatically internally. We can configure the counts if we want to, but for now that will be fine. The encoder, you'll remember, is connected onto MPG2, onto modIO 2, so we go to configure it, modIO 2, configure it, go to the MPGs tab. Right, it's encoder number 1, it's on terminals 14 and 15, and we want it to work encoder DRO1 on Mach, and we must enable the controls for it to work. Alright, on the settings screen there's the encoders, and if I turn the MPG, you can hear it turning, then the encoder senses it. We can change that configuration so that it works as an MPG for jogging fairly easily. Configuring this again, encoders, so now we're going to select it feeding MPG1. And we need to go to ports and pins. We disable that and we will enable MPG1. We will leave the default counts. The count and velocity are relevant here, but we apply that. Now you can see on settings the count working, and if we go to program run, tab activate MPG jog mode, and that's convincing, isn't it? Tab MPG mode X. Now we were in E-stop because of the ports and pins change. So there we are, we're jogging the X-axis. You can probably hear me. And so that completes using all the peripherals that I've set up on my two modIOs.